Hi, my name is Bria Long, and I'll be presenting Characterizing the Object Categories to Children See and Interact With in a Dense Database of Children's Naturalistic Visual Experience. And this is joint work with George Cooccurrence, Nidhi Bhatt, and Michael C. Frank. If I show you an array of colored pixels in different locations on this screen, you can really easily derive meaning from what you see. Instead of seeing colored blobs, we all see bikes, bunnies, couches, and cups. There's some incoming visual input that gets transformed and makes contact with the wealth of knowledge that we all have about these objects and the categories they belong to. But if we think about it, we of course know that we weren't born with this knowledge. Somehow we had to learn how to connect visual features with their appropriate visual concepts. So how do we build visual concepts? One way of thinking about the answer to this question is to think about the regularities in infants' visual experience. In other words, how they learn from the statistics of their experiences with different categories. For example, how will this infant, who is at the very beginning of her journey into language and category learning, how will she learn, for example, what whales are? And while she's probably heard the word whale before, she's probably heard it in the context of her bath toy, and this could be kind of confusing because these two things look relatively different and also are poor approximations to an actual blue whale. So how is she going to learn the word whale? Understand that it refers to all three of these things: stuffed animal, her bath toy, and the largest mammal on the planet. Over the past decade or so, researchers have begun to record the perspective of infants using infant head-mounted cameras, documenting the world from the infant perspective and gaining insight into children's everyday learning environments. And so here you can see examples of the infant view from in-lab play sessions, which have generally revealed that the infant visual experience is far from our own and relatively hard to intuit. And more recently, researchers have taken these cameras out of the lab and into the home. We can start to see what it looks like to learn about these categories, to think about how children actually experience couches, cups, rabbits, or birds. And so today, I'm going to be asking, what are the regularities in children's everyday experiences with these kinds of visual concepts? As so far, most of the research in this area, including my own, has been focused on the social information and the infant view. So first question is, how stable are the broad characteristics of children's visual experience over early development? In fact, some of the work on the social information and the infant view has found really dramatic changes over the first 2 years of life, with the views of the social partners containing relatively close-up views of faces earlier in development, and later on containing views of hands manipulating objects. However, we've also seen that the activity context that children participate in, like mealtime or story time, can also shape the social information and view, and also that the physical environment in which children learn words is relatively important. So in some work, when children hear a word in a very specific spatial location, like the kitchen, this word then tends to be learned earlier versus later in development, suggesting that these activity contexts may shape early learning. So here, we're simply going to ask whether activity contexts like mealtime or story time versus children's age are better predictors of what tends to be in view. The second question I'm going to try to tackle concerns the distribution of the categories that children interact with in everyday activities. So at present, most of our models of category learning, and certainly the most robust ones, learn from uniform distributions of different category studies. They see equal numbers of exemplars of birds as they do couches. And most studies that have examined statistical learning mechanisms have also assumed uniform distributions between categories. And so a critical question going forward is, how unrealistic is this assumption? And what is the actual distribution of categories that children are learning from? A landmark study has started to answer this question by annotating all of the objects in the view of 8 to 10-month-olds, who see a few objects very frequently during mealtime, like spoons and cups. And they also found that these are among children's first learned words. And in fact, there's some suggestion that these skewed distributions, which seem to be omnipresent in children's experience, could be really useful for learning. For example, these high-frequency objects could create known context for low-frequency objects, allowing learners to bootstrap the meanings of these relatively infrequent items. But at present, we don't know how generalizable this result is. We don't know if this is only about 8 to 10-month-olds during mealtime or more a general facet of children's visual experience. So today, these are the two questions I'm going to be attempting to answer, asking whether activity context versus age determine what generally tends to be in view for infants, and whether the objects that children interact with across a broader range of ages and activities also seem to follow a skewed distribution. I'll start with this first question. To give you a sense of what these videos look like, I want to show you just one short clip from the infant perspective. This is an infant playing at home in their living room with their caregiver who's off to the right, interacting with a toy that I now know is a walker. You can see there's a lot of things in this child's visual environment, including a cat that you may spot on that chair. And their caregiver is demonstrating some of the affordances of this object, talking about different aspects of it. The child's attention is also directed to other things in the environment, like a second cat that comes into view. This is one short clip from one video in the CACAM database, which is a longitudinal database of egocentric visual experience, where there's over 400 hours of videos from 3 different children, filmed from 6 to 32 months of age. And I want to note up front that this is a convenient sample. So this is 3 children of psychologists who are willing to participate in this study and have their children wear head-mounted cameras for a few years. Nonetheless, this is one of the largest and most naturalistic databases of egocentric visual experience, and it's filmed across really diverse contexts. So here are just a few example frames. Sometimes children are outside, walking around their garden. Sometimes they're hanging out on their crib, crawling on the floor, or eating dinner with their parents. And so using this naturalistic database, we can start to gain insight into the early learning environments of these few children. So here our analysis sample is going to be 24,000 random frames that are sampled from these 2 children. These children were the ones that had finished filming at the time that we started the project. As a first step, we wanted to try to figure out just what was going on in these images. So we designed a task to characterize children's visual environment where we asked participants to select all of the categories that were present in an image. So you can see the categories that we selected to the right, including animals and their toy or drawing or real versions, other generic baby toys, utensils, dish, food, furniture, book, person, clothing, plants. We also allowed annotators to say, there's something else here, like another small object or a large object that doesn't fit into one of these categories, or if there's nothing visible or none of the things that you've allowed me to choose from. And so our main goal here was just to get a broad sense of what's going on in these images. And we chose this list after kind of iteratively piloting and looking at these images ourselves. So for this image, someone would have chosen a real animal because there's a cat. The other toy, that walker, is quite present. There's furniture and then other small and large objects. It's a pretty cluttered scene. So here are some annotation examples. Here are frames where food was annotated, where toys were present, where furniture was present, and where real animals were selected as present. Sometimes annotators did disagree on what was in an image. For example, glossy photographs sometimes got classified as real animals by some annotators. But generally speaking, when there were disagreements, they were about kind of partial views or occluded images, where it was really hard to see what was going on. And if you're interested in exploring this data set, all of these annotations are publicly available. So using these annotations, we can now ask, how consistent are the broad characteristics of visual experience over early development? So for each category, I'm going to plot the proportion that was detected as a function of the children's age in months. For each color is going to be data from one of our 2 children. And so broadly here, we're just asking how much change is there over development and how much diversity is there across these 2 children. And broadly, what we see is relative consistency. So some things are much more frequent than others. So children are seeing many more people than they are toy vehicles. But we don't see a lot of change over this developmental age range. And these 2 lines for these 2 different children are relatively close to one another in all of these cases. So we see consistency both across time and across our 2 participants in the broad characteristics of their environment, in contrast to work on how children see people, these more fine-grained measures of visual experience. So we can also ask whether these visual categories co-occur predictably, perhaps by different activity contexts. So here, what I'm going to do is plot the frequency of occurrence for each category relative to every other category, where lighter values are going to indicate a higher probability of co-occurrence. And go ahead and looking at this data, what we see is some relatively structured co-occurrences. So there's a reliable structure in which categories co-occur together. For example, Books, people, and furniture often co-occurred in the same frames, perhaps indicating story time. We often had toys also co-occurring with people and furniture, maybe living room playtime, and food and dishes reliably co-occurred together as well. So instead of developmental change, instead we see relative consistency with patterns driven by activity contexts. So in answer to our first question, we see relative stability over early development in these two children. That seems to be driven by the activities they participate in. Second, we're going to tackle the distribution of the categories that children are actually interacting with. And we want to know in particular whether the objects that children interact with across a broader range of ages and activities also follow a skew distribution, much like the initial study by Clark and al. And so here we're going to look at objects that children are interacting with in frames, with the logic that children likely have the most intensive experience with objects they manipulate, that they can pick up, and that they might be learning the names for these objects. So we decided to analyze a set of frames where children's hands were present. This is from a previous study where we annotated this. And so we have frames where we know that we can see children's hands, and then we could annotate what children were pointing to or holding on to. And we ourselves went through and annotated these in a set of nearly 2,000 frames, and there were about 1,300 that actually had objects in them. And I'll note that we had separate entries for both drawings of dogs and dogs. So we analyzed this both ways. We did actually annotate these as separate different things since they have really different ways in which children interact with them. So here I'm going to plot the top 20 categories that we saw infants interacting with in these frames. These are the top 20 out of the 180 categories roughly. And the question here is whether this follows a skew distribution. And indeed, this is what we see. So there are a few categories that are present in most of the frames: books, toys, and people, and relatively low frequency of everything else. So there's a very skewed distribution of categories, and we see a lot of books, baby toys, and people. So one natural question is whether the skew distribution is being driven by these top three categories. And so what we did next was to exclude these from our analyses. So we reran the same analyses while excluding books, toys, people, and food, which was also a very frequent category. And so here I'm going to show you the frequency of the next 50 categories for each child. And what we can see is that in both cases, we still see a really skewed distribution, suggesting that this is a really general property of infant visual experience and not driven by the particular categories in this data set. So in general, we see that the object categories that children are interacting with in a set of frames also generally follow the skew distribution, extending the prior work from Clark and al. However, I think broadly speaking, these results point to a need for more general and broader measures of visual experience. And in current work, I'm starting to fill this need by moving on to new methods, thinking about crowdsourced photographs, where we can ask parents to take photographs from their child's perspective and get samples from a much more diverse set of participants. And also adapting parent surveys to assess children's visual experience with different object categories. For example, asking in what formats their child has seen a giraffe. And using a pilot version of a parent survey, we already see some intriguing correlations. So here on the x-axis, I'm going to plot 3 different measures of visual experience: how often children see a given category, how many exemplars they've seen, the number of formats they've seen, that's drawing, real life, toy, etc. And on the y-axis is the average age of acquisition of different nouns from the word bank database. And in all 3 cases, we see a correlation between these coarse measures of visual experience and parent reports of early word learning, suggesting that there's a real link here and that we can use these broader measurements. Even so, the results that we have now, I think, still have implications for models of visual concept learning and word learning. So it seems like children learn within activity contexts that structure their visual experience, from skewed distributions of different object categories, and from representations that span really different visual formats. In contrast, our best models learn without any contextual information, from uniform distributions of categories, and from curated photographs, suggesting that in order to create better models of visual concept learning, we really need to start taking how children learn more seriously. When we think about early language acquisition, we can now think that, well, children's visual experience is probably as skewed as their language experience. This provides real constraints on the types of learning mechanisms that can succeed in this environment, where there are learning contexts where some words and reference are very frequent and many are very rare, raising the question of how often children are learning visual categories before mapping words to them. I think that to make progress in understanding early category and language learning, we need to take the visual environments in which children learn quite seriously. Thank you for listening, and I'll be happy to take any questions